Here we are at the last section in the Calculus 2 course and continuing with the polar coordinates. We're going to start doing calculus in this section with polar coordinates. And so we'll start with area. We'll start with integrating. So if we're looking at some region bounded by a polar curve and by particular rays, so we have this angle theta and then this second angle theta, and then we're looking at the curve that's the area that's bounded in this region. We can find the area by this formula. A equals the integral 1/2 r squared d theta. Now, actually, where this comes from, if I guess we don't need that, but if you have a circle, in fact, let's not even put the axis, but if you have a circle and you want to find the area of some sector of the circle. So we go from the center, we're cutting off some part of this circle. Then the area of that sector is 1/2 r squared theta. So we have r as the radius, there's some angle theta there. And so the idea here is we're going to take little sections of this circle that obviously would have a radius of r, and then d theta would be the width of that. And so then we add them all up and we get our integral. So that's where this formula comes from. So let's look at an example. So we want to find the area enclosed by one loop of the four-leaved rows, and that comes from r equals cosine 2 theta. So we are looking between negative pi over 4 and pi over 4. So let's set up our integral. So the area is the integral from negative pi over 4 to pi over 4. 1/2 r squared d theta. Now, r squared is cosine 2 theta. So obviously, we're not integrating with respect to r. We are integrating with respect to theta. So we need to write this in terms of theta. So let's write the integral from negative pi over 4 to pi over 4, 1/2 cosine squared 2 theta. Now, maybe I'm sure we've probably done a cosine squared. We haven't done cosine squared 2 theta, but we can still use this identity. Cosine 2 theta equals 2 cosine squared theta minus 1. But we actually want this angle to be 2 theta, which would make this angle to be 4 theta. So we can use the same identity, but just adjust the angles. Make this cosine 4 theta, and then 2 cosine squared 2 theta minus 1. So now we have cosine squared 2 theta. So let's solve this equation for that. So then cosine squared 2 theta would be 1/2 plus 1/2 cosine 4 theta. So let's do a substitution, an identity. So we have 1/2, and then cosine squared 2 theta is going to be this side. So 1/2 times 1/2 plus 1/2 cosine 4 theta. And now if cosine doesn't have an exponent, it's very easy to integrate as long as this is linear also. So we'll actually factor out a 1/4. So we can distribute the 1/2, but that'd make it 1/4 plus 1/4 cosine. Let's pull out the 1/4. And then we have the integral negative pi over 4 to pi over 4, 1 plus cosine 4 theta. And then we can pretty easily integrate this. We just have theta. We can do a substitution if you like, but I think we just see that we'll have 1/4 sine 4 theta evaluated from negative pi over 4 to pi over 4. So then we have 1/4 and plug in pi over 4. So we have pi over 4 plus, now 4 times pi over 4 would be pi. Sine of pi is 0. So we have 0 and then minus. Now let's plug in the negative pi over 4. So negative pi over 4. Again, sine of negative pi would be 0, so we can just subtract 0. So this is pi over 4 plus pi over 4. So 1/4 times pi over 2, which is pi over 8. And there you go. All right, then the next thing and the last thing in this section, it's a very short section, is arc length. And so this comes from, so we have the arc length of this polar equation is going to be the integral from a to b square root of r squared plus dr d theta squared. And we're integrating with respect to theta. And we can derive this from the arc length formula that we saw earlier in the course, but I won't do that now. So, and actually I didn't want to do this one. We're gonna change this. I changed this one in the notes. R equals 5 cosine theta. I forgot to update that. And we're gonna go from 0 to, so the length, integral from 0 to pi, square root r squared plus dr d theta squared. We'll just write the formula and then we'll fill it in. So r squared would be 25 cosine squared theta. Dr d theta, we can take this derivative, dr d theta, just take the derivative, and we get negative 5 sine theta. So plus negative 5 sine theta squared d theta. This is the integral from 0 to pi, 25 cosine squared theta. This will be plus 25 sine squared theta. And so this is just going to be 25. So we can factor out the 25. We have cosine squared plus sine squared. So this gives us the integral of square root 25 d theta. This, of course, is 5. So that integral will be 5 theta evaluated from 0 to pi, which is just going to be 5 pi. So very straightforward. Just learn a couple of formulas and no big deal on this section, I don't think. So you may have one or two that the integration is not as easy as this, but it's not going to be anything too difficult either. If you know your trig identities, you can probably manage your way through that. So, but in any case, if you have any questions, please let me know.